Well, our first video together, huh? We're about to jump into the wonderful world of trigonometry. Learn about triangles. More triangles. We'll disguise it. We'll make you think it's not a triangle. It's always going to be a triangle. Every single time. Even when I start talking, it's not going to look like a triangle. It's a triangle. So, as we do our journey, I'd like you to remember that trigonometry is always about a triangle. No matter what, we force stuff into it. But to get started, so we can start talking about triangles, triangles have, oh, look at that in the word, try, 3 angles. Angles, we got to talk about angles, all right? And there's 2 different ways that we can talk about angles. In degrees, where most of us are pretty comfortable, we have an idea about degrees, most of us. And then there's this other way of describing an angle, it's not really an angle, but we describe it this way, is a radian. So we need to learn how to speak both languages. Radians are really good for engineering and actually doing things with them. Degrees are cool for explaining and understanding. They're wonderful. Because I don't know about you, but I'm much more comfortable with the idea of 145 degrees rather than 1.7 radians. And 1.7 radians doesn't make sense to me, and I'm the teacher. Okay? So degrees, they're great for explaining, but radians are going to be better if you're one of those future engineers, physicists, or maybe you just need to get into physics. We got to know a little bit about radians. All right, let's go get it. Now, angles, as I said, can be measured in degrees or radians. These are the 2 different things, 2 different ways. We're going to learn a little bit about radians in our next one, in our next installment, and it's going to be designed so you can do your homework. All right, I'm going to try to make sure that these videos are designed to not waste your time, but really maximize your time. Now, these intro videos, maybe I'm not going to do a lot of the homework problems, but this is going to get your foundation to understand what the heck's going on. So, let's start talking about some angles. They're important because we're going to be learning about them. Well, here's something I snatched straight from your book. By the way, your book's pretty good. It's interactive. It comes with that subscription and everything. Go look through it. Check it out. It's got videos and stuff. Maybe it's it's got to have higher quality than the shit you're going to see here. All right, so let's look at our first one right over here. Now, the vertex, that's chill, right? That's the point where two rays come together, but don't stress about that. That's not what we're really looking at. Let's look here. We have what's called the initial side. The initial side, and just by the word, like English, initial, it's where you start. It's the beginning. And then we have a terminal side, and just in the word, we can say, hey, that's where it terminates. That's where it ends. Now, we don't typically write our angles this way, but we can. And as you can see, it's sweeping out in this direction. And let's put an angle in there. Now, for the first time, I'm going to put in your theta. Theta. Just a Greek letter. And it's used a lot when describing an angle. We're going to use other Greek letters as well to describe angles. And I'll just kind of throw them in there. Instead of X's and Y's, but when we talk about angles in trigonometry, many times we use Greek. So don't be scared of the Greek. When you see Greek, you're like, angle. No big deal. I see Greek, angle. All right. So theta. Cool. So we have where it starts and it begins, but that's not the way we write it. Let's look at our next one. This is much more as to what we're going to be messing around with. This is how we want to get this stuff set up. With an X and a Y axis. You remember that stuff? Isn't that beautiful? You know something about this. Trigonometry is not algebra. It is something very different. It takes a while to get used to seeing it. So having anything we can tie back to algebra is beautiful things. And I know that we have experience with algebra. And maybe not so much with the trigonometry. So we have it sitting right on your XY axis. And this is where we're going to start all our angles. We're going to start them. The initial side. This initial side is on the positive x-axis. Always. We start there. Okay? So, and if your terminal side is here, in our second quadrant, slip that in there, second quadrant, it's opening up in this direction. Hey, that's how we can measure an angle. From our initial side, which is always going to be our positive x-axis, up to our terminal side. Cool. Cool. And now let's give it a name. Let's give it an angle. Let's call this, I don't want to go with that one yet. Let's go with this one. Just getting you some Greek in Hey, old alpha. Alpha. It's like the Jesus fish, right? I bet there's some sort of tie together there. I don't know. No, like the alpha. I know. Okay, moving on. Moving on. Little alpha. It's like A in the English language. Beginning. Okay. Now let's move to our next piece and let's keep describing. What the heck is going on? Well, it looks like we can have a positive angle and we can have a negative angle. But our initial side is still right here. The initial is that positive x-axis. So depending upon which direction you're going to travel, it's either in the positive direction or in the negative. So this is our positive direction going around. And if you remember first, second, third, and fourth quadrants from past classes, that's the direction it goes. That's the positive direction. As long as it's going 1, 2, 3, 4 in that way, that stuff's positive. Take that or leave it. We'll be back to it, but just thought I'd throw it out there. And I'll call this one again alpha. And I'm going to say alpha is a positive angle. Alpha, in this case, is a positive angle. In this case, not always. It could be negative in other cases. And then let's say that this one down here, we're going negative, and we're going to call this angle, let's call it beta. And beta is a negative angle because it's going in the negative direction. So beta, there's another one that we got. So we got alpha, and then we got beta. Right? Looks like a B, kind of like B. Yeah, there we go. So let's go back to this thing though real quick, and I just want to do an approximation. I just want to look at this thing and go like, alpha, let's go, what do I think about that thing is in degrees? Let's think degrees. It looks like it's bigger than a right angle, right? Huh? From here to here? That's more in the right angle, because a right angle would be right up here. So I don't know, I'm going to call it like 120 degrees, about. Yeah, just talking shit. Now let's look at beta and be like, what do we think beta is about? But since it's in the negative direction, we got to make sure to write a negative on it. And I'm just looking and going, how far? From there to there? Is that quite 45? I don't know, maybe I'll just call it negative 40 degrees. I'm just kind of giving you the idea. Because for this one, we're starting here, but we're going back the other way. Okay, so that's by going clockwise, you're going in the negative direction, and when you're going counterclockwise, you're going in the positive direction. All right, fun with angles and some Greek. So we're getting alpha, beta, theta. We got a few of them. Let's play some games. So let's talk about where we start. We begin right here, 0 degrees. That's where we start. So if we didn't go anywhere, if we were just to draw this in, we'd be like, if you just gave me that, that's 0 degrees. It doesn't open up at all. It doesn't change. It doesn't do anything. That's our initial. That's where we start. That's where we're pointing when we begin. Now, if we were to make ourselves a nice little right angle like this, right in between here, wouldn't this be 90 degrees? That'd be 90, right? Cool. So there's 90 degrees. Well, let's go talk about what would happen if we were going to go from, we got our 0 degrees here, we know 90's up here now. What if we were to do a 180? A 180 would just be 90 more. So we'd be over here at 180 degrees. A straight line actually has an angle of 180 degrees. Now, if we keep going around, it's 90, 90, 90, 90. So we're going to see, now I'm not going to actually draw it. Well, shit, I'll do it. What the hell? Start at 0. We go to 90 degrees. We go to 180. What comes after 180? That's 180 plus 90. That's going to be 270 degrees. So now if we wanted to start here, go all the way around. There it is. There's 270 degrees. So this one here, so let me start labeling. Alpha's 90. This one's beta is 180. This one, let's call this one theta. And let's say that theta is equal to 270 degrees. And then, I mean, I got to do it. I got a fourth one. Let's jump in there. let's do the whole dang circle, huh? So we start at 0 degrees and we're like, all right, let's go to 90, let's go to 180, let's go to 270, and then, oh, if we went all the way back around in the circle, 0 degrees and 360, wouldn't you end up back in the same spot? If you jumped up in the air, you spun around and you landed at 360, wouldn't you be pointing the same direction you started? Hell yeah, you would. So there we go. We go all the way around in the circle, and there's 360 degrees. Maybe let's call this one phi. Old phi is equal to 360 degrees. Hey, there's another one. Doesn't phi, or you might call it like phi theta kappa. It's weird. I call it phi when we're talking like sororities or fraternities or clubs. Boom, math. That's phi. Yeah, trippy. All right. Last couple things. I want to talk about how could we end up back at 90 but go the other direction? What if we were to go this way? What angle would that be? What angle would it be if we went the other direction? Well, if this is also 360 degrees, right? It's also 360. Huh. Let's think. So the first one's, that's a 90, 90, 90. Wouldn't that be negative 270? Negative 270 degrees because you went 90, 90, 90? Huh. Okay. Okay. So negative 270 and 90. I wonder how far apart negative 270 and 90 degrees are. I wonder how far apart those are. I don't know. Now let's go the other direction on this next one. It'd be like, well, if we were going the other way and we wanted to get to that point, wouldn't this be negative 180 degrees? Okay. And now if we went all the way to 270 degrees in the positive, how do we get back to there going the opposite direction? Wouldn't this be just negative 90 degrees? And how far apart is 270 and negative 90? How far apart is 180 and negative 180? How far apart is 90 and negative 270? And when I say far apart, what's the difference? 90 minus negative 270? I think that's equal to 360 degrees. Okay, cool. I'm going to do this over here, and we'll go 180, and let's subtract out that negative 180. Let's find the difference between those two. And that's equal to, oh yeah, that's 360 degrees. And then I'm pretty sure if we take 270 and we subtract out negative 90, I'm pretty sure we get 360 degrees. So there's a little bit of fun with the angles, your positives and your negatives. It's going to get you started in your homework. I know that this is a lot of stuff right off the bat, but we'll be back and we're actually going to discuss radians. No more of the degrees for just a little bit. See you in the next one.